Alright, so before we learned from a chemical formula how to find the percentages of each element in a compound, and now we are going to go backwards from that. We are going to use the percentages to figure out what the chemical formula will be. So it's called the empirical formula, where the formula is in the lowest whole number ratio of atoms that are represented in the compound. So we use our percents to calculate this. So some examples are carbon monoxide, where there's 1 and 1. When you look at the subscripts, basically, the only thing that they're both divisible by, all the subscripts in the compound, would be a 1. So for my poem, this is to help you discern and figure out how to go about doing this. There's 4 steps. So step 1, percent to mass. So that just means that if you have a percent sign, you change it to a gram sign. And then you're actually going to put that number over 1 to set up some dimensional analysis. Okay? Step 2 is mass to moles. Well, on the mole map, to go from the mass circle to the mole circle, it says to divide by the molar mass. And M stands for molar mass, where it'll be 1 mole over the molar mass. And that's going to be the molar mass of the element. Okay? Then when you get all of those numbers, so if you have 3 elements in the compound, you're going to have 3 numbers. Whatever it is, you look at them and you divide by the smaller of the 2 numbers, or 3 numbers, or 4 numbers. And then after you divide by the smallest, you round to a whole number, which it will be, if it's not exactly a whole number, it'll be super, super close to a whole number. So if it's 1.99, round it up to 2. So we're skipping example 18 just because it's a little difficult, and we won't have anything like that on a test or a quiz. But example 19 is exactly like what we need. So we have 67.6% mercury, 10.8% sulfur, and 21.6% oxygen. So we have 3 elements, so we're going to keep the 3 elements separate. The symbol for mercury, which we haven't seen for a while, is Hg, hydrogyrum. Then we have sulfur, and we have oxygen. So now we get on with our poem steps. So step 1 is percent to mass. So we're going to write the percentage given in the problem as grams over 1 for all of them. So for mercury, it's 67.6 grams over 1. For sulfur, it's 10.8 grams over 1. And oxygen is 21.6 grams over 1. So that's step 1. Step 2, mass to moles. So for all 3, we're going to put 1 mole over the molar mass of that element. So mercury is not always used by us, but that molar mass is 200.59 grams. Sulfur, 1 mole over 32.064 is what I have. And oxygen, everybody probably has that memorized now, is 15.999. Excuse me. So if we divide all those out, and we're just going to go 3 decimal places because it really doesn't matter. So we have 0.337 for mercury, and about 0.337 again for sulfur, and I have 1.35 for oxygen. So now we evaluate. We're on step 3. We pick the smallest one to divide all of them by. Well, it just so happens that in this case, mercury and sulfur have the same number. So, and that is the lowest. So we're going to divide both of them, actually all 3, by the same number, where the mercury and the sulfur work out to be 1s, because something divided by itself is 1. And for the oxygen, when you divide that, I got 4.006-ish. So this is where step 4, round to whole. Mercury and sulfur are already rounded, but oxygen will round down to 4. So if you did this, you get minus 1 point. You need to have these as the subscripts in a chemical formula. So the formula of what I'm looking for is Hg. If you'd like to put the 1, you can, but there's 1 of them. There's 1 S, and there's 4 O's. So a chemical formula like that is what I'm looking for to see where those numbers fit into the chemical formula. All right. So this is going to be the front side of the empirical and molecular formula practice paper, and the back side will be on video 8.